In this video, we will look at the case of solving two inequalities simultaneously, or in the next example, solving at least one of two given inequalities. So in this example, we want to explore the simultaneous inequalities. We want to know what values of x will solve 3x plus 7 is greater than 1, and 2x plus 1 is greater than minus 4. So what we're going to do is just proceed through solving each of these. So in the first inequality, we can subtract 7 from both sides and rewrite this as 3x is bigger than minus 6, and then we can divide both sides by 3. So x is bigger than minus 2. And what we would like to know is for what x values do we simultaneously solve both of these? So the ampersand sign just means and. So 3x is greater than minus 6, and, while looking at this other inequality, subtract 1 from both sides. 2x is bigger than minus 5. Divide both sides by 2. X is bigger than minus 5 halves. So to write down our solution, we're thinking x is bigger than minus 2, so that would be minus 2 to infinity. And whenever we say and, that becomes an intersection symbol. X is greater than minus 5 halves, so minus 5 halves to infinity. And putting this on a number line, we have minus 2 and minus 5 halves. So the first inequality is solved for x values which are to the right of minus 2. The second inequality is solved for x values which are to the right and not including minus 5 halves. And what we would like for our solution set is the overlap of the two, which x values simultaneously solve both of them. So putting that in here in black, we have an open circle at minus 5 halves, and we go to the right. So the desired solution is going to be the open interval minus 5 halves up to infinity. And the important observation in this example is that the and sign really becomes an intersection. Let's look at another example where instead of trying to simultaneously solve both of these equations, what we would like to do is figure out what x values will solve one or the other inequality, so at least one of the two. So once again, we just go ahead and solve each one of these inequalities individually. With the first one, we can subtract 1 from both sides, so minus 5x is bigger than or equal to 10. And then in the next step, what we can do is divide both sides by minus 5. So I would have an x on the left, and on the right we would have 10 multiplied by minus 1/5. And recall, whenever we multiply or divide by a negative, we need to change the direction of our inequality. So this inequality now is x is less than or equal to, so this would be x is less than or equal to minus 2. And we now want to solve the second inequality. So 7x plus 3 is bigger than or equal to 4. What we can do is subtract 3 from both sides, so 7x is bigger than or equal to minus 7, and then divide by 7. X is bigger than or equal to minus 1. And when we write down our solution set, the or becomes a union. So the first interval that we get, x less than or equal to minus 2. So that would be minus infinity to minus 2, and the or becomes a union, x bigger than or equal to minus 1. So closed interval at minus 1 up to infinity. In terms of a number line, we are looking at everything which is not at minus 2 but to the left of it, including minus 1 to the right of it. So we have our solution written in interval notation, as well as having sketched the solution set as well. And once again, the big observation is that the or transfers to being a union when we get down to our solution.